Hi guys, in lecture 5 today we will discuss the special right triangles in which the two angles are 45 degree each and another angle is 90 degree. So we draw a triangle, a right triangle in which this angle is 90 degree. So we name the triangle as ABC and these two angles are given to be 45 degree each. This one is 90 degree. So in the triangle in which the two angles are equal, that is said to be an isosceles triangle. So we write in triangle ABC, angle A is equal to angle C, both are equals to 45 degree. So this means the sides opposite to these two will also be equal. So it's the property of an isosceles triangle. So we write side opposite to angle A, BC, and opposite to angle 45 or angle C is AB. So these two sides are equal. We write since ABC is an isosceles triangle. First we will find out the hypotenuse by assuming the equal sides as some variable. So let BC is equal to AB is equal to x units each. So we assume these two as x. According to Pythagoras theorem, AC square is equals to AB square plus BC square. So AC square will be AB x square, BC is also x, so it is x square. So AC square is 2x square, or AC can be written as square root of 2x square. So x square outside the square root it is x. So it is x square root 2. From here we can write the hypotenuse is x square root 2 units. That means in the right triangle in which the two angles are 45 degree each and the sides we have assumed as x, so hypotenuse will be x under root 2. Now we find the trigonometric ratios of the angle 45, whether we can take A or C, it will be equal in both the cases. So let us take the reference angle. Angle C, which is 45 degree. For the reference angle C, this is the opposite side, which is x. Hypotenuse is x square root 2 and the third remaining side will be the adjacent side. So from the relation SOHCAHTOA, we can write sine of this reference angle 45 degree. This is opposite upon hypotenuse. Opposite is x, hypotenuse is x square root 2. So it is 1x here, so x gets cancelled. It is 1 upon square root 2 and since this is radical, so we rationalize it and write it as square root of 2 upon 2. So the first one we get sine 45 degree is equal to square root of 2 over 2. Same way, cos of 45 degree. From this one, it is adjacent upon hypotenuse. Adjacent is x, so it is 1x over hypotenuse is x square root 2. X gets cancelled, so it is 1 upon square root 2. Again square root of 2 is there, so we rationalize it. So it is square root 2 into root 2 it is 2. That means cosine of 45 degree is root 2 upon 2. From this relation we can write tangent. Tangent 45 is opposite upon adjacent. So opposite is x, so it is 1x. Adjacent is also x, that means it is 1x. So x gets cancelled, so the result is 1. That means tangent 45 degree is equals to 1. Now the reciprocal of sine, it is cosecant, so it is cosecant 45 degree is the reciprocal of this one. So reciprocal of this expression will be 2 over square root 2. So which we rationalize and write it as 2 square root 2 multiply root 2 and root 2, it is 2. So this gets cancelled, that means it is square root 2. So cosecant 45 degree is square root 2. You can see that we can directly from this expression also we can write sine 45 degrees 1 upon root 2. So cosecant 45 directly can also be written the reciprocal of this expression as square root 2. Otherwise also if you simplify, again we get cosecant 45 as square root 2. Same way the reciprocal of cosine, so it is secant 45 degree. Again it is the reciprocal of this expression, so it is 2 over square root 2. Rationalize, so it is 2 square root 2, multiplication of these two is 2, so it gets cancelled. So square root 2, so secant 45 degree is square root 2. Then the reciprocal of tangent 45, so it is cotangent 45 degree. So which is the reciprocal of 1? So reciprocal of 1 is 1. That means cotangent 45 degree is equals to 1. So this way you can find all the trigonometric ratios of angle 45 degree, whether we take the reference angle as angle C or angle A, since both are 45 degree, the values will be same for it. Now remember the triangle. This is 90 degree. If these two are given to be 45 degree, in this case if one side is given, we can calculate the remaining two sides by using the concept. Always remember this will be taken as x each and this will be x under root 2. So we take the example on this. We take a triangle. These two angles are 45 degree each. This side is given to be, let us say, 5. So find remaining sides. So if you compare with this one, always remember this is very important. Always remember this triangle and the sides written in this form. So from comparing the two triangles, we get x is equals to 5. That means the side AB is 5, side BC. We are comparing with this one. So BC is x, that means BC is also 5. And hypotenuse is x under root 2. That means the hypotenuse here is AC. So AC is x under root 2. That means AC is x, we have written it is 5. So it is 5 square root 2. So we can find the sides. If one side is given, whether it is the perpendicular or the base or the hypotenuse or opposite adjacent or the hypotenuse, if any one of these sides is given, we can find the remaining two sides by comparing with this triangle. So we take another example on this. Naming it as ABC. If this is given to be 20 square root 2. So you have to find the remaining sides. So again comparing with this triangle. If you compare with this triangle, so the hypotenuse. So we write hypotenuse, this is 45 degree given each. This has to be there, otherwise we cannot compare the triangles. So these two are 45 degree. So we write the hypotenuse is 20 square root 2, and comparing with this one we get it is x square root 2. That means 20 square root 2 is x square root 2. So these two sides are x. So from here you can see square root 2 gets cancelled, so it is x is 20. That means the two sides AB is 20 units and BC is also 20 units. The hypotenuse is 20 square root 2 given. We take another example in which the hypotenuse is now given in some different form. You can see here. ABC is the triangle. This is 90 degree and these two angles are 45 degree each. So this one is given to be 16, let us say. So we assume these as x. Comparing with this standard triangle, this is x square root 2 and x. So we write hypotenuse is x square root 2, but in this question it is given to be 16. So x square root 2 is 16. So x is equals to 16 upon square root 2, and we rationalize it. So it is 16 square root 2 upon 2. This will be cancelled. So x is 8 square root 2. So you can see here the sides, equal sides, AB is 8 square root 2 units and BC is also 8 square root 2 units. So we can find the remaining two sides whenever one side is given. So this is the way we do these questions. So hope you have understood it properly. So if you have liked the video, please give a big thumbs up and also share it with your friends. So see you in the next video. Okay, bye.